Hello everyone, we're Group Shrinkage. We're here to present our deep learning project. Our topic is online common toxicity detection and classification. Here is the agenda for today's meeting. Toxic comments are very detrimental to our internet environment. In fear of getting toxic comments, people can be afraid of sharing their ideas online. Currently, the Conversation AI team funded by Jigsaw and Google are actively building technology solutions to protect our internet environment. They build Perspective AI for identifying and classifying toxic comments. However, it still makes mistakes due to unintended bias, such as associating the name of some identity groups with toxicity. For our project, we're building a multi-head NLP model that identifies toxicity in online conversations and classifies them into subtypes of toxic behaviors. The dataset used for this project is from the Kaggle competition, which includes 2 million public comments. For each comment, the rating of overall toxicity as well as 6 subtypes, which is generated by human raters, are provided to us as input. For visualization, we selected 3 sample comments, a toxic one, and a mildly toxic one, and a harmless one, and listed their training inputs in the table down below.
For our solution model, we tried BERT, LSTM, and ExoNet for this project, and we decided to choose BERT model as our final solution since it has the best performance. BERT is a very popular model in the natural language processing field. Each layer of BERT is a multi-layer bidirectional transformer encoder. Inside the transformer, it employs a attention model. The process of our pipeline is as follows. We first tokenize the comments and convert them into indexes. Then we fine-tune a pre-trained model. Finally, we use the model to output the prediction score for each subtype of toxic comment. In our case, since we are classifying the attitude of the comment before training the BERT model, we first tokenize the comment using BERT base case pre-trained tokenizer and convert them into indexes. For the comments, the tokenizer is unable to tokenize. We choose to truncate the tokens to length of 120. As for the model structure, we choose the BERT base model and fine-tune the hyperparameters except bias and the layer norm weights. Our model has 12 layers, 786 hidden size for each layer, and 12 self-attention heads, with total parameters of 100 million. We used Adam Optimizer and created a scheduler which linearly increases the learning rate during warm-up period and then linearly decreases the learning rate afterwards.
In order to have a clear view of the performance of our model, we selected several sentences that were classified as toxicity subtypes. From these 3 examples, we can see that our model can correctly classify each comment to their relevant subtypes. For evaluation, we use AUC, F1 score, precision, and recall as metrics, computed weighted averages across all the classes, and got the overall results as below. As you can see, our model achieved a high AUC and high precision, but got a relatively low recall and F1 score. Meanwhile, as the figure 4 shows, our model got a high AUC score for all the subtypes. We also plot the precision recall curve for each subtype and have some interesting findings. For subtypes like obscene and insult, the model performs well, but for the others, it performs relatively worse. The bad performance in identity attack may be because that our model tends to associate the names of frequently attacked identities with toxicity.
The Perspective AI also reported to have the same issue on unintended bias for identity. From various research, a set of harmless texts that mention identities, which is shown in the table, was fed to Perspective AI. From the table, we can see that Perspective AI incorrectly identified many of these comments as toxic. Also, mentioning identity like gay, lesbian, or black have much more toxic level than men, women, or white. In order to test if our model have an improved compared to Perspective AI, we tested the same dataset with our BERT model. Overall, our model has a better performance in dealing with unintended bias or mentioning of the identity. Using 0.5 as threshold, none of them was classified as identity attack. However, mention of certain identities still have an effect in our model. This can explain the low precision and recall value for the identity attack column. In conclusion, we implement a fine-tuned BERT model to classify toxicity of comments and their toxicity type. It achieved an overall good performance, and we also improved some internal drawback of toxicity classification. This is our reference. Thank you for watching.